Hey guys, what's going on? Hope you are doing well. We are gonna have here a series. I'm gonna go through. This is gonna be multi-parts, two, maybe three, if we need a third. We'll probably do a third as sort of like a cleanup. All around query manipulation. So that includes query decomposition and query augmentation. Couple things before we get started. I do highly recommend that you have some idea of how RAG systems work. I am going to go through one here briefly, but you should probably have a general idea of that, or some of the ideas that I talk about aren't going to make a ton of sense if you don't know like anything about RAG. So I do recommend that. Other than that, you don't really need anything else. Today I'm going to focus a lot around the ideas and the theories around why we want to do this and how it works and everything like that. And then we're going to go into a much more code-based version in the next parts of this series. So I do want to pull up a diagram here and kind of walk through it, and then we'll take a look at kind of what it means when we talk about query decomposition and query augmentation. So this is a RAG pipeline. This is a very basic version of it. For those that aren't overly familiar, this is like a chatbot style, conversational style system. So a question comes in from the user, and this one, how do I do X? We also have a vector database that stores, knowledge for us to use to reach an answer based on an LLM. So we are providing context to an LLM dynamically to answer users' queries, and that dynamic ability is based on semantic similarity between the query and the documents or files or whatever we have in the database. So we have our vector database where we upload a bunch of different files, stuff that you want to use as sort of your knowledge-driven generation. You have an LLM, and then of course you have the answer. Now the one piece here in the middle is embeddings. The question is embedded and then compared against embeddings of the documents in the vector database. They are then ranked in order from most similar to least similar, and we grab the most similar, stick them in the prompt of our LLM and say, answer this question, or provide an answer, or based on the user's query and based on these documents, answer the question, something to have the LLM generate an answer based on this dynamically pulled context. Very simple, very straightforward. An example here would be, how do I do this? We have in our vector database, let's say like FAQ pages or documentation. The semantic similarity between those figures out that, hey, this page from the documentation or this page from FAQs is related to the query. We pull it into the LLM, and then we ask the LLM to answer the question, how do I do X, based on the information that is pulled in the context, surrounding how you do that. And then we answer the question. Very straightforward. Now, this pipeline is very driven on the semantic similarity between whatever is talked about in our user provided query and the documents that we have in our database. And the way that most of these systems work, like I mentioned, is you rank the documents in order based on similarity, and then maybe you grab the top 3, top 5, top 10 documents there, put them all in the prompt, and answer the question. And that works really well when the query aligns with the information that's there. If a user asks a question that is just like completely unrelated, like let's say this is a chatbot on like your e-commerce store, and somebody asks, I don't know, something completely unrelated to shopping. Like they think it's ChatGPT. They're like, write me a marketing, paper or whatever. It's not going to do well because the semantic similarity between the query and the information that we've set up to be used to answer the queries are not going to be related at all. One is related to shopping on this store or the products that they have or something, and the query isn't. So this is very much driven based on the similarity between those two sides and how efficient we are at pulling in the correct document to answer the question. There are usually, multiple documents that can be helpful, but there's usually one, that is most helpful, especially when you look at like testing and evaluating these systems. You want to identify the document that should be used to answer that type of question. That's sort of the recall that we have from our ability to recall what files or text documents from the vector database are related to our query. Now, where this gets interesting is queries that are more complex. They maybe, aren't as straightforward semantically. Everything I'm talking about is like semantically. Like to us, they might be straightforward, but to a system that just looks at the semantics between both sides, maybe they're not overly semantically similar, or they don't contain the right information, or they're too short. Queries that are more complicated, this is where this gets a little bit weird, because really the key aspect of this, the driving force behind the system, is the ability to recall relevant information based on our query. If we can't do that, you're really out of luck. I tell customers all the time that the ability to retrieve the correct documents in these type of systems is really that's really the most accurate your system can be, the rest of the system. Because if you can only recall the correct document 50% of the time, how is the rest of the system going to be better than the 50%? The LLM isn't going to be able to answer the questions correctly. You're not giving it the right information. So when you get queries that are a little bit more complicated, I'll show us an example. One of the key ideas is being able to restructure that query to better fit a format for search. Remember, we are still doing a semantic search. So being able to sort of restructure and reformat our queries into something that better aligns with our information helps our model, right? If we know that when a user asks something that isn't overly similar, but we just know from our domain knowledge that it is, if it read a little bit different, it would be better. Then we're able to do that. Like, let's say, here's kind of a weird example. Like, let's say we had a e-commerce chatbot. We've got all these products, and somebody says, I want a size 12 of the shoes with a swoosh on them. Semantically, that's not going to be very good. We're going to grab all shoes in that size, but we know the swoosh means Nike. But a semantic driven model doesn't know that. The word swoosh and these shoes in the database, unless they specifically say swoosh, aren't going to be able to make that correlation. That's just an in-domain sort of knowledge that we have as humans, that the semantic model just isn't going to pick up very strongly. It's going to be very focused on the shoe keyword. It's going to be very focused on size. It's not going to be easily able to make that correlation between swoosh and Nike. But what we can do is, what if we had a model there in the middle that looks at the query, decides or not if we need to restructure it based on our own domain knowledge, and rewrite it, right? In that example, maybe we rewrite it as, size 12 Nike shoes or whatever. We change out the swoosh part for a brand keyword, and our understanding of how these searches should operate allows us to do that. That's kind of I would say a little bit of an interesting example where you really have to decide if your domain specific knowledge is worth sort of structuring down further. Query decomposition is going to be much more easy to see in terms of why we want to do it. That's a little bit more of query augmentation, where we're taking a query and we're just restructuring it in another format. Query decomposition is going to look a little bit different. So I want to run through an example here and kind of show you what the idea is behind query decomposition, why we want to do this. So let's say we have let's say we're a we're LangChain. Let's say we're LangChain. If you're not familiar with LangChain, please go look at it. We are LangChain, and we have all of our documentation, all of our FAQs, all of our blogs, all of our YouTube videos, all of these loaded up in this knowledge base so that people can search and be able to get the knowledge that they need. They're able to sort of figure out the documentation, figure out their issues much more efficiently. We've loaded all this up in a vector database. We're ready to go. And somebody asks this question: what are multimodal models, and how do I use them? How do I use them? Yeah, we'll leave it. What are multimodal models? How do I use them? It should say in a chain, and turn the chain into a REST API. That's something, if you asked me that, I could answer it pretty easily. What I would do is I would tell you what multimodal models are. I would tell you how you can use them in a chain and LangChain, and then I would tell you how to turn a LangChain pipeline into a REST API. Very easy. I can answer that question for you. But let's kind of think about this from a RAG pipeline perspective. When we look at this question or this query, what info do we pull? The idea that there's a FAQ page that tells you this exact thing, what a multimodal model is, how do I use it in a chain, and then how do I turn that chain into a REST API, is probably super low, right? Like, I mean, unless you wrote a blog doing specifically that, it's probably very low that we are able to pull context that is directly related to all three of these ideas. These are three things that you could ask on your own. And I bet you if you ask them on your own, they would do really well, because you would do what are multimodal models, and we probably have, we're able to just grab a blog page or something that says exactly what multimodal models are. How do I use multimodal models in a chain? Sure, there's documentation and a blog post or something related to that. And then how do I turn a LangChain chain or system into a REST API? I know for a fact there's documentation on that. So when we look at this query sort of in pieces, it's very easy to know what exact context we should grab from the knowledge base to answer them. But when we look at the question as a whole, as it was presented to the model, that's not clear at all. What would probably happen is you would pull document. I bet you this query is super semantically similar to any FAQ around multimodal models. I'm sure we grab documentation. Remember, all you can grab is just the ones that are most similar. When we talk about that basic RAG pipeline from before, we're going to put this query in, we're going to embed it, and we're going to semantically compare, and we're going to grab the top 5 results. And I bet you the results are focused on multimodal models. Maybe they're even focused on, chains or something like that, because we do mention that a couple different times. But we're only going to grab related to that. And what could actually happen that's worse is that because we have so many different topics in this question, we actually struggle to grab anything related to any one of these 3 topics. We have just such low similarity scores compared to the files that we have that are just very focused on one topic, that we struggle to do that. So what we need to do, and what really makes sense from a theory standpoint, is, well, what if we could break this into topics, right? What's a multimodal model? How do I use multimodals in a chain? Or maybe you do like, what is a chain or something like that? And then how do I turn a LangChain chain into a REST API? What we really want to do is break that into topics, search by each topic, and grab the top result from each topic and give that to the final model. So instead of our LLM getting 3 documents that are all related to the embedding similarity of this entire string, we grab one of each per topic. And then that's a much easier question for the model to answer, because no context is missing. We have removed the idea of context not being able to be provided. Because if you put this in, and let's say we do grab 3 relevant documents and they're all related to what are multimodal models or how do you set up a multimodal model or something like that, it would just hallucinate how to turn that into a REST API because we're not able to grab any context related to that. I'm sure we would grab documentation related to a REST API, but maybe it's not related to multimodal models specifically. Maybe it's not related to multimodal models in a chain. You see how we kind of need to do multiple searches with each of the topics and then how those topics correlate to each other in this question to grab context for each one of them. That is the goal of query decomposition, is taking these queries that are multi-question, multi-part, multi-topic, things like that, breaking them down into subqueries, searching on each subquery, and then using the documentation or the information that is pulled based on those queries, each subquery, to answer the final one. So, our model, and what we use LLMs for this. You want to use, something like, we usually use GPT-4 or, maybe one of the small ones or something like that, where your prompt is really something like, and we'll see this when we go through the code examples. Here's a question, break it down into subqueries. And, what we would want is probably something that, here's our question. We probably want to teach the model to do something like this. What are multimodal models? How do I use... Once again, another idea here, if we were just to break this down just statically without sort of a dynamic model doing it, one of our middle ones would be, how do I use them in a chain, right? One of our subqueries would be, what is them? Unless we have the context of the step before, we're not going to be able to use that as effectively. Once we break it down in these subqueries, there's no knowledge of what the other queries have in them. So you really, and we'll see this, you really want to make sure your subqueries fully understand how they correlate to each other as well when we do this search. How do I use multi models in a chain? And then I turn a LangChain chain into a REST API. The other way that you can validate this, something that will probably make more sense to people that aren't as familiar with this, but still use Google. If you were to search this in Google, what would you get back, right? You would probably get something back, it ranks in order from Similarity, something related to multimodal models, but probably not the whole steps to go through this, unless somebody wrote a specific blog on how to exactly do this. But you would probably get results that are semantically similar to the steps here, but don't actually answer your questions directly. You would have to go through like different blogs and then grab each of the pieces and say like, okay, this is what multimodal models are. Okay, here's a blog on how to use them in chains, and here's a blog on how to turn chains into REST API. Right, but when we do this sort of RAG-based system, that's not how that works. We're grabbing our context, usually the top result, think about Google top result, and then answering it only based on that, or only the top 3 results, or something like that. Whereas if we did this, if we broke this query down, and we first searched Google for this and grabbed the top result, we then search Google for this and grab the top result, and then we search Google for this and grab the top result, and then we were to sort of look at all 3 of those ourselves, we would be able to answer that question. It's how people, forever have Googled. When you have something that's more complex, you sort of break it down into different tasks that you want to Google, and you grab the resources information, and then you're able to answer your question based on the knowledge of each of the steps. Same idea here. We're still doing a search system. We're still basing it on semantics. And we want to be able to pull in each of those based on that. So I did want to walk through this just so that this makes sense as we look at code examples of it. And there's a lot more that goes into this than just here's a query, break it down by topic or something like that. We're gonna see there's much more than that. Because you really want to ensure that each of your subqueries contains specific information that isn't missing based on the other questions. Like I mentioned, if this just was like, this was just them, then that doesn't work. That's not really going to work super well. If this said, let's say this actually didn't work, for whatever reason, because let's say multimodal chains were different than like standard chains, then we'd want to teach our query decomposition prompt to do something like, how do I turn a multimodal model LangChain? So we'd want to make sure that that's a little more specific, and that just takes some testing and things like that. We, from the business side, use query decomposition and query augmentation all the time. It's one of those systems where when the query is simple, doesn't do anything, just lets the query go through and go from there. And when it's something that's more complex, it operates and does its thing. So it's a nice little safeguard for when users use more complex queries that have multi-steps and things like that. And that's a fairly standard reason for this, is multi-step questions like this, where they could have done each of these questions individually, but they just decided to do one. This is probably the most common thing that you see when you look at sort of why these systems are used and things like that. But yeah, and then the other one is query augmentation. So like I mentioned, in more complex use cases, it's doing things like changing the language itself so that it's something that is more domain specific, but it could be as simple as, I'm trying to think of an example. Like, let's say this was, what are let's say it was like something like this, and we just changed it to just this, multimodal LLM models or multimodal models, removing keywords that, when we think about semantics, aren't incredibly relevant. Remember, when you create embeddings, you are creating an embedding of the entire string. So you're going to have some sort of value for this, value for this, this, right? You go through the whole thing. And so if your string is a little bit smaller or a little bit more keyword dense, you're going to get a score that's a little bit closer to this. Now, with a query like this, you probably wouldn't do that, because you probably have resources in your database that are exactly what are multimodal models, so you'd want to kind of keep that the same. But you'll see that in some instances where you just have additional words that don't provide a semantic value as much, in terms of what is the combination vector for my entire string, we want to make that as sort of use case specific. You'll see that you can remove some of these additional words that just don't provide a bunch of value, and can in some instances make it a little bit worse. Cool. Well, that's all I wanted to go through, just kind of the theory around why we do this, how we do this. In part 2, we are going to dive into some real examples of how this works, how you can test it. We'll run through some code examples and some things like that. I highly recommend, like I said, you have a good idea of RAG before you go into that episode as well. I think it's going to make it a little bit easier. You'll understand some of the concepts a little bit more. But if you're able to get through this video, I think you'll be fine as well. So that's it for today. Part 2 will be out shortly after, and we will go from there.